Hello everyone. Today I decided to record a little tutorial for you. Not even tutorial, but last tips before test 2. Of course, I can't reveal you all the problems which are going to be there in test 2, but at least and I can't reveal you topics as well, but at least I can give you some helpful tips. At least I hope they are going to be helpful. So what are these small things which could be really annoying? First of all, let's talk about topics we discussed during the last 3-4 tutorials. It was all about, as you can remember, work integrals, about double integrals. So you definitely need to carry the list of standard integrals with you. So the first question which I needed to discuss is about your cheat sheet. Of course, everyone compiles its own cheat sheet according to their style and everything. But I think that one thing should be clear for all of you. As your last 3 or 4 tutorials contained a lot of integral, that means that you need a table or list of integrals. So don't forget to put a list of integrals into your cheat sheets. No, the most basic ones, of course. Don't go for these very, very long lists which contain like 30 or 50 formulas. No, I think it's around 10 or 15 is enough. Just the basic function, exponential, sinus, cosinus, and so on. Just, almost from school. And the next thing, you notice that we had to differentiate quite often. We discussed problems like calculating gradient of the function, which involved finding partial derivatives. Also, there was Laplacian and so on. So all our problems involve a lot of differentiation. That it means that you need a list of derivatives, of course, list of derivatives as well. So this is my recommendation for you. When it comes to comparing your cheat sheet, it's a good idea to include, some at least basic list of these things, integrals and derivatives. Okay, what about the second thing, the second question which I need to raise now with you? We calculated quite a lot of integral recently, and of course I did give you, hints as to how to do it, how to approach this task in the best way. But nevertheless, I want to repeat it once again. So let's take, for example, very very small example, very basic integral, super simple. So it looks like 2x squared dx. So you are required to calculate this integral, very simple one, from -1 to 2 from this function. There's nothing easier than this task, but the most annoying thing is at the very end when you need to substitute these limits of integration, and that's where most of the errors come. And for you, of course, it will be very, very annoying to get your score for this particular problem reduced only because of arithmetics, only because of your carelessness. That is why uh, I maintain that you should write as much as possible when you do this very super simple task. Okay, so what is the antiderivative of this function? It's pretty obvious. 2x cubed divided by 3 from -1 to 2. And after that, people usually, as I said, students usually get relaxed and they think, oh, it's just a piece of cake to calculate this thing. But no, 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 don't do anything like this. You need to be especially focused when you do this, as I said before. So how can we reason? I think the best way to approach this task is to realize that you need to substitute this guy's 2 and -1 instead of x only, instead of x cubed. And this guy, 2 over 3, should be treated as a common factor, and that is why we can just um, pull out this common factor and rewrite this expression like this. Okay, so it means that we'll have to rewrite it all the time, but it's not such a big issue. We can rewrite it quite easily, and then we can put up like parentheses or brackets here. And it will be super convenient to substitute 2 and -1 here. And again, don't be tempted to write immediately 8 instead of 2 to the power of 3. Just write it like this, minus, especially here, -1 cubed. So this is best approach. This is what I'm actually doing all the time, even though I have quite a big experience in mathematics, as you may imagine. But nevertheless, I know that this place is the most treacherous. So I always do like this. Maybe you might laugh at me, but at least I never get wrong answers. And so look at this. This is, place is especially unsafe because -1 cube is -1, and minus times 1 minus will be +1. And this is the most, typical mistake many people do, many students do. Okay, now I can simplify it a little bit, and the answer is 6, of course. Yes, 6. So as you can see, this is a super simple task, but I wanted to point it out to you that be very careful, be very, very focused, especially at the end of, this integral, because that's where the most of the mistakes come, students. And it's very frustrating to have a reduced score only because of these stupid mistakes somewhere here. And we do need to reduce your score because according to the rules, we can't break the rules. Okay, so hopefully I managed to convince you to be very, very careful about these things. The next thing which I want to discuss with you is are repeated integrals. Repeated integrals. This topic is relatively fresh in your mind, I hope, because it was the topic of our last tutorial. But nevertheless, I want to draw your attention once again to the fact that uh, I denoted this repeated integral in a little bit different way to make things more clear, more convenient to you. And that is why let's consider some repeated integral and discuss it one again. So in our tutorial sheets, and as well as in the test, of course, they prefer this format. So they write two integrals next to each other. Let's take this integral, for example, next to each other. So they look like this. So this is a format which is accepted in our tutorial sheets. It means that the same format will await you in your test 2 and your exam as well. So how did I approach this task? I prefer to rewrite this integral in a more convenient form, in a more convenient for calculations, for transformations, and so on. So to do that, you can put parentheses or brackets around the internal integral. Right? This is like a first step. Then you can move this guy, differential dx, in front. So integral from 1 to 2 dx. And the internal integral can be rewritten without parentheses. That's the convenience. So dy. And so this format is very popular as well, It's very popular as well. So these are two different ways of representing repeated integrals. So I prefer this one, and your tutorials, they prefer to use this one. But I think that the best idea is to use them both, because this form is more convenient for calculations. Even though you wrote the integral from the left to the right, so you wrote dx first and then integral dy. But when you start calculating them, evaluating them, you're moving sort of from the right to the left. You start integrating this function over dy by dy, and only after that by dx. So that's what I wanted to point you out. I'm not going to calculate this integral. Hopefully you know how to do it. You can always watch tutorial 8. Tutorial 8, I don't remember which part 2 probably it was. You know better than me. I don't remember this name of the tutorials already. Okay, so please be aware of this. And as for the answer, if they ask you to write the repeated integral, so you can use either this form or this form. I will understand you. It's going to be me who's going to check your exam papers. So don't worry about it. Don't stress out about it. I will equally expect either this form or this form if it should be given as an answer. So this was a little tip about repeated integral. The next thing, a very interesting thing, concerns notations again. Notations, especially when it comes to nabla operator. So let's discuss a nabla operator a little bit first. Again, we already discussed it long ago. I think it was tutorial 6. I'm not sure though. So nabla operator. You know what is, guys? This usually denoted by nabla, like this, and this is a very strange vector, which is actually not vector but symbolic vector, because it contains these blank spaces here instead of function. So d over dz, and I usually pointed out these blank spaces for you. But I made things a little bit easier and clearer to you by putting this arrow. on top of the vector. Whereas in your tutorial sheets, they never do this. And maybe it's inconvenient in terms of font. I don't know what's the reason behind it. Or maybe they want you to develop your mind, better. So it's expected if you look through your tutorials, especially beginning from tutorial 6, when this nabla operator was first introduced, you will notice that there's no arrow on top of it, and this might lead to the confusion. So, and it's absolutely unacceptable to lose valuable time during your test, trying just to understand what they want, what do they want to do for me, what is this operation means. So let's discuss it. Of course, we discussed that there are nabla operator is used in actually 4 situations. 1, 2, 3, 4. Let's make 4 columns to go over them again. So the first operation looked like this: nabla arrow F. Okay. The second operation was nabla dot some, I don't know, F, maybe this one. These letters don't matter at all. I'm just making them up. So there was this operation. And finally, we had nabla squared like 5. So you're pretty familiar with these notations. And so that's what expected to be in test 2, of course. But so, sometimes the problem is that they don't put these arrows above these vectors, and that is why you might be confused. So my suggestion is just let's try and rewrite these expressions without errors, to get you prepared for the format. So in this case, it will look like nabla f. This will look like nabla dot f. And this is definitely will look like nabla cross f, and this will look the same actually. Nabla, this thing is nabla operator, which is not nabla operator. What is it called? It's called Laplacian. If you remember, this is Laplacian. Laplacian. So as for Laplacian, I think that you already have a cheat sheet. Laplacian is like the sum of the second derivatives. It will be written like this and that. I think no problem with the nabla. It's easily recognizable. And this guy is very recognizable as well, even though you don't see any errors at the top of the vector. But this cross sign is very, very helpful. You immediately realize, this is a cross product of 2 vectors. By the way, they do try to make things more clear to you by denoting vectors in a bold font. So, for example, if they mean that these 2 guys are vectors, they make them explicitly bolder than the rest of the font. So like this, and here as well. But you know what? But what if the font is not very clear? What should you do? I think these 2 cases are especially confusing. So let's go over these 2 cases. They look pretty similar. Look at this. Nabla F here, nabla F here. There is a dot here, but you might think that maybe they just forgot to print this dot. Sometimes they don't even care to print this dot. They give you something like this and something like this. And you can't see clearly whether this font is bold or not, or maybe similar to the rest of the font in your text. Also, it will be really annoying, especially with these new guys. You know what? I think the best way is not to rely on the visual representation of these guys, nabla and F. It's better to rely on your logic. It's, the best approach. When you understand things, you will never get confused by some, unexpected notation. So let's imagine that we have these 2 guys, nabla F and nabla F. These letters doesn't matter. I just wrote them differently just because it's better to use them. So how do you recognize which operation is hiding here and which operation is hiding here? You are not given any words like curl or divergent, nothing like this, just nabla operator. You know what? In the first place, you need to realize that nabla is a vector. That is why I just put the arrow above the vector, and you realize, so I'm dealing with one of the vector operations. But what is this operation? They both look very similar, and I deliberately omitted this dot, in front of them, because dot means scalar product, of course, dot product. But I deliberately omitted it so to make a situation really real. So what can you do? You need to think logically. You know that I have 2 operations or vectors. Let's just memorize. So the first operation from the past was, multiplying vector by some constant k. And in this case, sometimes they do write this dot. Sometimes they just write it very, in a careless way, just ka. So it looks like this is the operation which means multiplying vector A by scalar. So it might be this vector, and this might be this operation as well. And there is another operation which is scalar product of two vectors. This is a different operation, of course. I'm not going to write it to you. You already know this operation. So how they are not? What can we do? What should we do not to get confused then? You know what? The best thing, as I said before, to use your logic. You need to look closer at your given data. What is this guy f? If f is a scalar function, something like this, so it plays the role of scalar, like k here. So in this case, you are dealing with the first operation. So this is a vector nabla which gets multiplied by constant by scalar. It's better to call it because it's not scalar, by vector. And how this operation is determined? You just multiply every component of this vector by this constant. So in this case, we can write this formula as we can just write this vector d over dx, d over dy, d over dz. This is our nabla. And here we can put just f, without this argument, because, and so you realize, so this operation should go just like this normal multiplication of vector by the scalar. It means that every component of null vector gets multiplied by f, but in our case, it's not quite multiplication, it's just substitution of this blank space. So it will be df over dx, df over dy, and df over dz. That's it. Maybe you recognize that this is a gradient vector, actually. Maybe you recognize it, but it's not the most important thing. Because what I'm going to show you now, how to recognize operations behind these notations, which are not very clear, which don't have these arrows on top of them. You can just think logically. When it comes to this multiplication, there are only two operations, only operations of multiplication some vector by constant. In our case, it's not constant, it's a scalar. And the second operation is dot product. And your objective is not to get them confused. And to determine which operation you are faced now at the moment, you need to look at the nature of this given f. So, I went over the first case when f is a scalar. So this operation looks like this. Okay, what is the next step? If you're running out of space now. So what if you're dealing with this sign and you have no idea, what is this? Is this a dot product, or maybe it's just, again, multiplication of my vector by the scalar? You need to look at the nature of f. What is f? And if you f given in this form, you need to recognize, this is a vector. Only vector can have three components. Okay, so you put arrow above it, and you realize, of course, this is scalar product. I can restore this dot between them. So this is it. And as for scalar product, let's try and practice our skills. So nabla is the same vector with these three symbolic components, and f has these components. And how can we do this operation? You know the scalar product, of course. So the first component here gets multiplied by this component plus the same with the second, and so on. So it will be dp over dx plus dq over dy, and finally dr over dz. That's it. Maybe you recognize divergence in this, but maybe not. It doesn't matter. We are not discussing these concepts now, divergence or gradient or whatever. We are discussing as how to deal with this nabla operator once again, even though we discussed it in the past. Because sometimes the notation might be very confusing. The problem is that I was making your life a little bit easier by putting these arrows on top of each vector. But as a result, the things which are written in our tutorial sheets and tests may be a little bit confusing to you. That is why I decided to discuss this topic once again. So hopefully I clarified things a little bit for you. Okay, so tip number 5, or topic number 5, or whatever, I don't know how to say it. Let's recall such thing as gradient. We just came across the gradients a minute ago. So what is the gradient of the function? Gradient. Let's not write down the formula. Let's just try recall the meaning of the gradient. So if you are given some scalar function, f or phi, doesn't matter. This is scalar function or scalar field. Remember, scalar field. It's better to use these terms, scalar field, in our course. So what is the gradient of the scalar field? Gradient is the vector which shows the direction of the how to say, in which direction the function f, scalar function, increases the most rapidly. So the gradient is the direction in which function f, or scalar field f, increases the most. This was the idea behind gradient. This was the reason why it was invented at all, increases the most. So if you can imagine the mountain, and you want to go to the summit, so which direction to move to get your elevation? Elevation is the your scalar function, the altitude above the sea level. So this is obviously gradient. If you move in this direction, you will get increase in the weight the most rapidly. What about the asking you about decrease? What about decrease? Decrease. Just the opposite thing. You need the opposite effect. You need to find the direction in which to move to get the most rapid decrease. So for example, you are somewhere in the mountain or close to the summit, all of a sudden you decided to go back. You might not feel well, from altitude sickness or something, and that is why you need to get to the foot of mountain the most rapidly. Which direction you need to move? The answer is pretty obvious. You need to move to the direction which is opposite to gradient. There is even term in the mathematics, anti-gradient, but we are not going to use it. For you, the most important thing is to realize that if you ask to gain the most rapid increase, you should move in the direction gradient. But if you ask about the opposite thing, you need to move the opposite direction, anti-gradient. So it will be minus gradient, this direction, of course. I hope you realized it. So it was a tip for you. Watch out for your assignment. Read carefully every single word, because sometimes people are asked to do something with decrease, but they don't notice this word because they are in a hurry. The time is precious and so on, and they do increase instead. And of course, it leads to to some reduced score, of course, which is really frustrating, because you know all the material, you understand everything about gradient and anti-gradient, but you just didn't notice this just because of the carelessness or just. Okay, so this was the second topic which I want to draw your attention to, that you should be very, very careful when reading the assignment. And the last tip, concerns reading assignments as well. This font is a little bit too small. I will try to move it closer. You know what? It's super important to read your assignment carefully, actually. I'm not lazy to say it again and again to you. As an example, of course, I can't reveal the tasks, problems from the test, no way, of course. That is why I decided to use this tutorial aid sheet, just to give you an example how should you approach reading assignment. Reading assignment is the first thing which you need to do, how to read your assignment properly. If you read carefully, look at this. So let's look at the first task, but I myself can't see properly. Oh my gosh, I need to read a line. Sorry for the interruption. It's quite dark in the room and I can't see properly this small font. Now you can't see. It's you who can't see properly. Okay, more or less. Okay, so let's start reading this assignment. You need to realize how many things I need to do. Some people just don't notice this. They are such a big hurry. They keep looking at the watch, at the timer. And as a result, they do only one assignment out of several, out of two or even three. Let's read it. For the following vector fields F, show that they are irrotational, then find the potential function for F and evaluate the line integral, and that's enough. So how many assignments do we have here? Some people say, oh, yeah. I need to show that this is irrotational. And that's all that they do. They don't notice the rest of the phrase. Then find a potential. So find a potential is the second assignment. So show that the irrotational is just assignment number one, the first thing you need to do. Find the potential is assignment number two. And look at this word and. It's a very, this is a keyword here. And evaluate the line integral. So this is assignment number 3. So do something like this when you come to the exam. In this case, you will never forget to do all the assignments which are required in your particular problem, and you will never lose marks, at least for this. At least for this. So I think this was very valuable tip for you. And finally, the last recommendation concerns the order in which you need to solve your tasks. What is the best order? Many people, many students just before prefer to do problem 1 first, then problem 2, then problem 3. But maybe this is not the best approach, because it's always better to start with the problem which seems the easiest to you, because that's how you save your time. And besides, which is not the least important thing, you will get very inspired after solving the first problem so wonderfully, and that is why there will be no problem for you to move to the next one. So my recommendation is start with the easiest problem. For you, it may not be, maybe the first problem it won't be the easiest for you. Maybe you will like a problem 2 or problem 2 first. So do it first. Then after that, move to the problem which seems not the most difficult for you, and finally leave the most difficult problem as the last one, because that's how you approach time management, in the best way. So this is it for today. Hopefully these tips will be useful for you tomorrow. So good luck for everyone.